Okay, today I'm going to show you how to do the Lab 1 for the ENGR 1025U Engineering Design course. You guys will be requested to make this part here. It's just a simple bracket for a shelf, and we'll do that using SolidWorks. To start, we'll open a new file. So at the top of your SolidWorks window, click File and New, click Part, click OK. We'll have this blank window here. We'll start with a new sketch, so at the top we'll click under the Sketch tab, Sketch, and we'll click on the top plane. See how it highlights the plane that says top plane? So now we're sketching on the top plane. We'll start with a center rectangle under the rectangle icon. We're going to specify the origin for the center of our rectangle, and then we'll click and drag outwards. We'll dimension this rectangle by clicking Smart Dimension at the top left under the Sketch tab, and we'll set our dimensions to 240 millimeters by 240 millimeters. If you haven't already, you should ensure that your modeling setup is in millimeter units rather than inch units. To do that, at the bottom right here we have a drop-down menu that offers different standards of unit measurement. We'll use millimeters, grams, and seconds, so mmgs, which you will always work with when you're working in this class. So just quickly switch it to mmgs if you haven't already, and make sure that your dimensions are all in millimeters. So here we have 240 by 240. We'll then create a tangent arc by clicking tangent arc under the arc icon. We're going to specify the top left point of our rectangle, and then we're going to drag directly to the left. We'll reach down and click the bottom left of our rectangle to make this semicircle. We'll trim the line in between the semicircle and rectangle to give us one constant path. To do that, click Trim Entities. Your default should be Power Trim. You'll want to switch to Trim to Closest, which is the bottom left here. Trim to Closest. Now we'll select the line in between the semicircle and the rectangle. It deletes that line from the intersection point here and the intersection point here. That's what Trim to Closest does. Once you do that, you'll see you have this continuous path, which we will then use to create an extrusion. To do that, we can click the check mark, we can click Exit Sketch, and now if we rotate our view here using the View Orientation icon, we'll switch to Isometric. We can see in a 3D view what our 2D sketch looks like. Now to make this a 3D solid body, what we'll do is move over to Features tab and click Extruded Boss. It should automatically highlight the last sketch that you were editing. If it doesn't, very simply you can click on your Sketch 1 or Sketch 2 or whatever the name of the sketch is under your Feature Manager tree. Then click Extrude, and it'll have all the information of that sketch selected so that you can create the extrusion. We'll create a blind extrusion with a dimension of 20 millimeters. Okay. So we can see here it's generating a preview as to what our extrusion will look like once we're complete this feature. We go ahead and click OK. Now we'll create a new sketch on top of the extrusion we just made. To do that, go back to the Sketch tab, click Sketch, click on the top surface. Okay. Right click your new sketch and click this icon here. It's Normal to icon. Whenever you click the Normal to icon, it's going to set your view looking directly at your sketch. You always want to sketch in a 2D space like this, meaning that you always want to be looking directly at your sketch, because if you're looking at your sketch on an angle, say like this, a slight angle could skew your perception of where the lines connect, so you might actually click the wrong intersection point. Unless you're looking directly normal to the sketch itself. So always click normal to when you're editing sketches. Next thing we'll do is create a corner rectangle. So we'll click corner rectangle under the rectangle icon. We'll click the bottom right corner of our extrusion, and then we'll drag this new rectangle up to the top and click anywhere along this line. Okay, now that's going to specify the height of our rectangle to be the exact same height of our previous rectangle. You can see here we have these relations. these constraints displayed, that just means that those lines are going to be collinear to the lines up here. And this relation here just means that our corner point is going to be coincident or on this line. So we don't have to specify our height, but we will have to dimension the width of this rectangle. To do so, click Smart Dimension and click either the bottom line, the top line, or you can click the two lines themselves, and you'll see we get this dimension here for the width. Now the width of this rectangle will be 20 millimeters, so we'll click 20 and OK. We'll then exit the sketch, rotate our view again into 3D space so we can see what we're doing. So either use your middle mouse button and then move your mouse around like that, or click under the view orientation icon, isometric there. We'll then go back to features. We'll make sure our sketch is selected, which it is, and we'll click extrude, set our dimension here to 190 millimeters, and click OK. So now we have this new second face of our bracket. From here we're going to click sketch, we're going to click the sketch again, and we're going to sketch on this top surface of our bracket. So we'll click right there. Now we'll right click our new sketch and click normal 2, that way we're looking at it. We're going to make a new corner rectangle that is half the height of the last rectangle we just made. So we'll click either the bottom left or the bottom right, or top right, top left, it doesn't matter. And we'll create this rectangle that is half the height. So you can see as I'm dragging my cursor down the side of our previous rectangle, the Y dimension is increasing. We want to go to 120 because we know it's half of the original 240, but we can also see here that at Y is equal to 120 we have a snap point or an intersection point where SolidWorks is automatically selecting that point of interest, which is the halfway point of that line. So we'll click there. Now we have our rectangle. We don't need to smart dimension it because we already know that it's the exact same width of our last rectangle because we have these coincident constraints, meaning that it's 20 millimeters wide. And because it is coincident at the halfway point, we know that that's 120 millimeters high. We'll exit our sketch. We'll go back to the isometric view. And now we'll go to our Features tab and click Revolved Boss. Now make sure your sketch is selected before you click Revolved Boss, that way that sketch information is loaded into the feature. And you'll see here it's going to ask us to specify the axis of revolution. So for this revolve feature, we're going to specify the center of this rectangle. And you'll see as soon as I click that, it's going to create a revolution around this axis, which is going to give us a semicircle at the top of this extrusion. See? So right here we have that semicircle I was talking about. Now if I create this revolved feature, this new body, it will merge with the existing body, meaning that this half of the circle that is already inside of the extrusion, there is no effect. It'll just merge it and there won't be any overlap. So you can choose to set your angular dimension for this revolve to 180 degrees if you wish. They'll both have the same result. If you do choose to do 180 and you're having an issue with the direction, you can flip your direction here next to blind, this little icon here, which will give you the option to change the direction of your revolve feature. So right there we'll click OK. Now we have the two sides of our bracket. Next thing we'll do is go back to Sketch, click Sketch, click on the top surface here of our bottom half of the bracket. We'll right click on our new sketch and set normal 2. We'll create two corner rectangles at the top right intersection of our two faces and the bottom right. Okay, now we'll dimension these rectangles to be 20 millimeters high by 100 millimeters wide. They're both the same. Again, 20 high and 100 wide. Okay, now we'll exit the sketch. We'll go back to the Features tab and extrude these two. Make sure that your sketch is selected before you click extrude, that way it'll load both rectangles rather than doing them one at a time. We'll then set 100 millimeters as our extrude dimension. So you can see there we're going to create these rectangular gussets. We'll press OK. Next thing we'll do is a chamfer cut, which is here under the fillet or fillet icon. We'll click the drop down tab, we'll click chamfer, and now we'll specify the 2 edges of our last extrusions that we just made. So we'll specify this edge here and this edge here. Okay. We'll keep the angular dimension at 45 degrees because we want to have a symmetrical cut, and we'll set our chamfer dimension here for 100 millimeters. That's going to give us a perfect cut 100 millimeters in from that edge at a 45 degree angle, which you can see here is going to result in our gussets being cut into little triangles. Click OK. So we should be at this point here now. Next thing we'll do is create a new sketch on the bottom face again. Right click, sketch, click normal 2. We're going to create a center circle at the center of this arc here. Now to place the center of the circle at the center of this arc, we're going to highlight the arc with our cursor, and you can see that while I highlight that arc, the center point is lit up here. We'll then click that center point and start our new circle. We'll dimension the circle by clicking Smart Dimension and clicking on the outer radius. It's going to ask us here our diameter of that circle. We're going to specify 50 millimeters. You'll know its diameter because you'll see this icon here. There's a circle with a line slashed through it. That just means diameter. So make sure your diameter is 50, not your radius. Right there, you can see what I'm talking about. Now we'll exit the sketch. We'll rotate again into 3D view here. You can select isometric from the view orientation. We'll go back to features. We're going to select the last sketch that we created and do an extruded cut. So we'll click extruded cut here. We'll specify the direction. You can flip your direction if your cut is in the wrong direction. So if your cut is upwards, it's not going to cut through the body. So you may have to flip your direction so that you're facing into the body. We'll specify through all as the type of cut. So this will just go through the entire body and anything on the other side of it. And in this case there's nothing, so we might as well just go right through. And we'll press OK. Now we have our first cut. We'll do the same thing on the second face. We'll sketch, click the top of that face, right click the sketch, click normal 2, pick center circle, highlight the arc, click the center of the circle, dimension this circle 50 millimeters. Whoops, that should be 50, not 100. Okay, we'll change that to 50. There we go. Exit that dimension, exit that sketch, back to features, extruded cut. We'll make sure it's in the right direction, and we'll select through all once again and click OK. So there we have the part for Lab 1. The next step to complete the lab will be to create a drafting file, which I'll do in a separate video. But to open that draft document, all you have to do is go up to File, save your current part wherever you'd like to place it. I'm just going to leave it here on my desktop as Lab 1. Okay, and then we'll go back to File and click Make Drawing from Part. So once we do that, it's going to open up a new draft document, which I'll continue with in the next video.